Hello everyone, hope you are doing great and welcome to my video. So, most of the interview questions on multi-threading will be asked based on the real-time situations. They will be giving you, they will explain some scenario, okay, and they will ask you to provide a solution using multi-threading. Now, if you see that there won't be any direct questions nowadays, no one are asking, like how you use synchronized keyword or what is executor service. These kind of direct questions no one are asking nowadays. Mostly everyone expects you to provide a solution based on the multi-threading concepts. So that is the reason now in this video I'm going to explain couple of concepts or areas from where interviewers picks the questions or pick the scenarios. Okay, now the first one is synchronization. Okay, and you know what is a synchronization means. So synchronization is nothing but one thread will access a resource and other thread should wait until this thread releases the resource, right? So that's where multiple threads do not interfere with each other's execution. And why? Because to avoid race conditions and to avoid data inconsistencies. So that is the primary reason. That is the reason we go for synchronization when we are working on the multiple threads. Now, don't think that synchronization means using synchronized keyword. Okay, so synchronized keyword is one of the approach to achieve synchronization. Remember that. Okay, I will show you what is the synchronization and what level of synchronization that we can handle in Java, and what kind of questions that are asked in the synchronization. So let's see that. Now take an example, a simple illustration where multiple players can join into a chat room. There is a chat room and it has some capacity. So the capacity may be, let's assume 10 in the sense up to 10 players only can join into the chat room. And the members section shows how many members are joined to a chat room. Okay, so and this chat room has two methods, join player and leave player. So join player in the sense whenever a player has joined to the chat room, they will invoke this join player, and a player can leave from the chat room as well. Okay, these are the functionality. And if you take the player class, it has two functions again, join and leave. So join expects a chat room to which chat room a player is going to join, okay, and from which chat room a player is leaving. Okay, so this is a simple illustration. I hope you understood the concept here. Okay, now let's code this first of all, and I will show you how the synchronization works here and also what levels of synchronization we can achieve at different situations. So remember the situations. Okay, I will explain that, you will see. Let's code this first of all. So let me open IDE, and I will create a package here, com dot maybe threading dot synchronization package, some package. Okay, so let's create a chat room first. Chat room is a class and it has two variables, capacity member and join player, leave player. So let's create that chat room. I'm just creating a class where it will have two variables, one is capacity, integer, members maybe. Okay, how many members or how many players are joined. Okay, and let's create another let's add the methods, public void join chat room. Okay, and let's create another one, leave chat room. That's it, these are the methods we are having. And assume whenever a player is joining to a chat room, we will increase the members count. Okay, whenever a player is leaving the chat room, we will decrease the member count. Okay, So just incrementing, if player 1 joined, members count would be 1. So let's create a constructor to have a default values. Maybe in the constructor I will say equal to 0 and this dot capacity equal to, and just statically giving 10 members. Okay, hard coding value to the capacity. Let's assume this chat room capacity is 10. Now if members count is greater than or equal to capacity, okay, because I'm starting members from 0, so if it is if the members count is 10 in the sense, and still I'm trying to add one more player, it should throw an exception, throw no runtime exception. I'm just giving a runtime exception. Chat room capacity is reached. Okay, and in the same way, if members count is less than or equal to capacity, in the sense already I have all the players are left the chat room and still I'm trying to leave the chat room. Assume that is the corner case. Okay, sorry, chat room is empty, cannot leave. Okay, let's say chat room is empty. Okay, yeah, I think this is pretty much okay. Now let's create our another class which is a player, okay, which has two methods, join and leave. So I'm creating one more class, player. It has two methods, as I said, join, and expects a chat room. To be chat room, the player should join. Okay, the moment player is joined to a chat room, so I'll just say chat room dot join chat room. Okay, and one more method, leave chat room, leave from chat room. So chat room dot leave chat room. Okay, so this is the player and this is the chat room. Yeah, we are good here. So this is a very simple case, okay, where a player will join to a chat room and it has some capacity, a limit. Okay, now let's create a chat room controller, maybe app controller something, okay, which is the front controller, maybe, where user request will reach to this class, assume. Okay, now let's create a main class. Here my intention is, let's say players count equal to 12. Let's say there are 12 players. Okay, each player, assume each player will join to a chat room via a thread. In the sense, if there are player count is 12, I will run 12 threads and each thread let a player to join to the chat room. That's what a thread does. Okay, assume maybe this is a controller, a Spring controller, and each and every request is nothing but a thread here, right? We are at a time we are getting a traffic. Now number of players are coming and number of players will join into a chat room. Okay, now as this is a main application, I am creating a threads manually, so I will execute 12 threads and for each player, and each thread will let a player join to the chat room. So let's create a chat room object first. Chat room equal to chat room. Good, this is a chat room. Maybe let's add one more thing here, room name. Assume there can be multiple chat rooms, right? So a player can join to multiple chat rooms. So chat room name, okay, so let's create, maybe let's say this is chat room 1. Okay, and I'm going to add multiple players, all 12 players, to the same chat room. Assume everyone are trying to join to the same chat room. That is the scenario. Int I equal to 0, I less than players count, I plus plus. Okay, to avoid confusion, let's start from 1 and equal to player count. Okay, now let me create a thread equal to new thread, and creating a thread, right? That is the reason I'm not going each and everything. So this is nothing but a runnable interface where we are implementing using the lambdas. Okay, so here will create a player for each count. I'm creating a player now, player equal to new player. Okay, now player dot join chat room. So now all 12 players, and see there is a player count is 12, and I'm iterating for 12 times, in the sense 12 threads, and each thread will create a player, in the sense there are 12 players. Each player will join to the chat room. My expectation here is, as this chat room is having a capacity is 10, okay, 10 players only should join to the chat room. Okay, if now player, if more players are trying after 10, if I'm still trying to add, it should throw an exception. That is the expectation. Okay, let's see what will happen. Maybe I will print the count also here to know how many are joining. Sorry. Okay. Chat room capacity plus members joined till now, maybe numbers added till now or whatever. Okay, numbers. So I'm just printing whenever a player is joined, I'm just printing the numbers count. That's it. Okay, so now let me start the thread dot start. Okay, did I miss anything? I hope not. Okay, so I'm running this. Okay, if you see here, let me see one. How many? The room capacity is 10. Now how many members are joined? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, there are 12 players are joined happily without any issue. Okay, and if you can see here, there are repetitive members count here. Okay, because whenever a player is joining, I'm incrementing the members count. Okay, and the state is getting changed by multiple threads here. That is the reason you are saying this, and most of you are pretty know about this because this is not synchronized, right? So that's where a synchronization is needed. So here multiple threads. Let me give a thread name here. Maybe a thread name is player fn I. Okay, just I'm giving for each and every thread, I'm giving a name. Okay, a thread name. Okay, now here, as you know, as this is not synchronized, what will happen is multiple threads will come to this point. When I say player.join, they will come to here, and multiple threads will try to join to the chat room, and multiple threads might see the same state, because this method is accessing the state here, right, which is a global one, and the state is not thread safe. That is the reason we are seeing these data inconsistencies, and we are seeing the same numbers because of the race conditions. Each and every thread try to modify the same state, right, at a time. Now to avoid these kind of issues, now we should have the synchronization. Let's add synchronization. So one of the way, as I said, using the synchronized keyword. The synchronized keyword I'm using in the method. So my expectation here is, so whenever a thread is calling this player.join, okay, and it is getting chat room, right? So whenever a chat room.join method, because I have added synchronized keyword to the chat room class method, right? So that is the reason whenever a chart room dot join chart room, this was called by a thread. Whenever a thread is called this object, I mean chart room object, gets locked. Okay, now when another thread comes to this join method, and when another thread, maybe a thread 2, try to access this join chart room, it will not get any access until the previous thread releases this, because whenever a synchronized method is accessed, okay, the respective object gets locked. That is the concept. Okay, just have this concept and you will see more wonders. Now let's execute. Great. So 1 2 3 4 5 6 7 8 9 10. Great. There are 10 members are joined to the chat room, and for the next player the 11th one was rejected. Okay, yeah, player 6 and player 3 are rejected. That's true, because when I'm running 12 players, any player can acquire the lock. Okay, that is the reason 10 players got the lock and they were added, and 2 were delayed, they were not added. That's what my expectation, and that is good. So now you think that this code is perfectly fine, and assume it's been 6 months we have written this code. Just let's assume, okay, after 6 months of period, maybe some other developer has looked into this code and they say, oh okay, we are printing something in the business logic or in the same function. Okay, maybe he thinks that instead of printing here, he might want to print as another method. He wants to give more appropriate follow more appropriate coding standards, and he will remove this line here which is printing the state, and he will add a new method. Okay, public void maybe get room info. Okay, which will maybe let's make a string return. Yeah, so maybe some other developer or maybe some your colleague has modified this code. Just he has removed the sysout and has added a new method. Okay, to modify the code and to get the things in a more real-time object-oriented way, maybe. Okay, so that's where he has added this get room info. That is fine. Now we have to change here, right? Because we have to call this info. Let's go to here, maybe in the go to player section. Maybe I want to print this after join chart room. Okay, so where I'm joining into the join chart room, I don't want to put any sysouts inside the chart room. I don't want to print anything here, but I want to print here once the call is successful. Okay, that's where I will write this get chart room dot get room info. Okay, just follow me here. So now let's see what will happen. I'm just running this. Okay, if you see here, the state is different again. If you see, yeah, only at a time 10 players are able to join. Okay, in the sense this is working fine perfectly. But whenever you see the state, okay, this syntax here, members down till now, it is again overlapped by multiple threads. In the sense, because this is not thread safe again, right? So okay, now as this is not thread safe, because here in the player class, first time chart room dot join chart room get called and object get acquired here. Now this get room info, definitely this is not synchronized, and let's make it synchronized. Okay, now you think that we have synchronized this get room info, okay, because it was not synchronized. That is the reason you are seeing the different states here. So now as we discussed till now, if you make synchronized keyword, it will become, we can achieve the synchronization, right? Let's execute this and see. Okay, do you see the expected result here? No, even though you are synchronizing this method, okay, still you are not getting the expected output here, because the member counts are, or the state is still get overlapped by multiple threads. That's what happening here. Here the concept, we have to understand the actual concept here. Whenever you apply any synchronization, okay, to a particular method, the object gets locked. That's what we understood. And whenever a resource gets released, the object gets released, definitely, right? Now here I have synchronized two methods, join chart room and get room info. Okay, but why still that state changes? Because these two are, I'm executing in a different different context in the sense, first of all, T1 executes this join chart room, assume, and T1 updated the member count as 1, and T2 come into the picture. Okay, now at that time T1 releases this lock and T2 acquired the lock. Okay, and acquire the lock in the sense this chart room object get locked, right? Now here what will happen, T1 will wait. T1 will not execute this get room info while T2 is executing the join chart room, because chart room object is locked by T2 and T1 will wait. Assume T2 is done with this job, okay, and T2 increase the member count to 2. Now T2 also comes here, and at the same time assume T3 came and it acquired the lock. Still T1 and T2 both waits here, okay, because chart room object is locked, because T3 is working on the join chart room. Now T3 is updated the member count to 3, fine. At that time T1 acquired the lock, okay, assume T1 acquired the chart room object lock. Now it will go to get room info. Now what will it print? It will print member count as 3, because T1, T2, T3 both are modified the state already by that time. Now members count is 3. Okay, now assume T2 also acquired the lock after T1's job, and T2 will get into the get room info. Now again members count will be 3. Again for the T3 also, whenever it executes this method, again the members count would come as a 3. That's where you will be seeing same members count for different threads. This is because even though you synchronized another method of the same object, still multiple threads are accessing both of the synchronized methods. That is the reason there will be data inconsistency still you will see. Okay, it will be there, you can't change anything. Okay, now what is the solution for this now? Okay, one of the solution is, maybe assume you still need this. Okay, then what you will do now here is, maybe one of the thing you will be coming into mind is, why can't I synchronize both of these two lines instead of applying the synchronization to chart room? Right? That is the idea you will be getting. Okay, let's do that. Maybe I have removed synchronization here, and I will apply synchronization to join method. Okay, so now our expectation is, I have synchronized the join method itself, and these two should run by one thread at a time, right? Because if thread 1 access this method, thread 1 will leave after the get room info method. Here it will leave, right? So these two should be in sync. Now my state should be in sync. That is my expectation when I apply synchronized on the join method. And now let's see what will happen. See, now what happened is, still there is a member state in data inconsistency, and also how many players are joined? 1 2 3 4 5 6 7 8 9 10 11. You see, I mean, even the join function itself is not working now. So what's happened? So why, even though I apply synchronized keyword to the join method, why still I'm seeing the data inconsistencies and race conditions? This is the important concept to understand again. Whenever you apply synchronized to a particular function, okay, as I said before, the respective object gets locked. In the sense, if you come here, how many threads I'm calling? I'm calling 12 threads. Now each thread creating a player object, right? When a player dot join, whenever I call player dot join, this player object gets locked. Now when the second thread runs, when the second thread comes into the picture, again there will be another player object gets created and the lock apply on the second object. Now the player 1 lock is different, the player 2 lock is different, both are different. Okay, hence this join synchronization, okay, whenever a object is gets called, each object gets its own lock. That is the reason all threads can acquire this join, can call this join function at a time, even to apply the synchronized keyword. Okay, I hope you understood what I'm saying. Let's take a notepad. Maybe here, before how it was is, okay, when I have applied the synchronized keyword to the join chart room, okay, the functionalities look like this. Chart room, this is the object. Okay, now T1 is there, thread 1, I assume, and it has created a player 1 object. Okay, player 1 object for the first iteration. Now then it will say, let's call P1. Okay, P1 is player 1. P1 dot join chart room. That's what happened, right? Now at the time the synchronization is on the join chart room, in the sense here whenever chart room dot join inside method, this method, what will happen? Chart room dot join chart room, right? This is the method will happen. This is the method that it will call. At this time the lock happened on the chart room object, in the sense chart room object is locked. Okay, now thread 2 came. Now player 2 object is created in the second iteration, p2 dot join, again same concept. Okay, chart room, inside join method, again chart room dot join chart room. That is what happened, right? Now at that time, assume still this chart room dot join chart room is still running, because the lock happened. What I said is the object gets locked, right? The lock happened on the chart room object. That is the reason the thread 2, and it will wait until this chart room object is gets released. Okay, so until the T1 finishes this job, this won't be gets executed. It should wait, because there is only one object here, only one object. Okay, and that object gets locked and unlocked for each and every thread. That is the reason synchronization worked here. But here now the case is I have applied the synchronized keyword on the join method, and here there is no lock on chart room. Okay, P1 came, P1 dot join. Now here P1 get locked. Okay, because the synchronization on the players join method. Now P2 came, P2 get locked. Okay, whenever I say P2 dot join, this P2 has its own copy of join function, right? That's how the objects work. Each and every object has its own members and state, right? Members and methods, right? So that's what it is happening. Now P2 and P1 is not at all related. So P1 has its own lock, so it can call this join. Now P2 has its own lock and it will call the join method. Both at a time can run this join function. Hence, even though he applied synchronized here, for multiple objects there won't be any synchronization works. Okay, so here till now the above case is object level synchronization. Even now still we are doing the object level synchronization. Okay, object level synchronization works for the respective object only. Whenever you access the same object across the multiple threads, then only object level synchronization works. Okay, so that is the reason here it is not working. Okay, because we are using different objects. Okay, now how to solve this? That's where a class level synchronization comes into the picture. Okay, Now if I do this synchro, I'm sorry, synchronizer of sorry, play dot class. This is how you will call the class level synchronization. Okay, now what will happen is, here we are not locking at the object level, we are locking at the class level. In the sense, whenever a p1.join happens, okay, a player class itself gets locked. p1 is instance of player, right? Now whatever the instances you do create for this particular class, all instances will get locked. Now when I say p2.join, okay, this class itself is locked now. So until this p1.join finishes, it won't get executed. That's where the class level locking comes into the picture. Now see, let's execute this. See, now it worked. Okay, so that is what a class level synchronization. And one more thing, in interviews, couple of interviewers might expect that class level synchronization, in the sense nothing but adding the synchronized keyword to the static methods. That's how they expect. Okay, and that is also true. Okay, that is also, whenever you have static methods, when you apply synchronize it to the static methods, class level synchronization happens. Okay, keep that in mind. Okay, but your method no need be static every time to achieve the class level synchronization. Okay, so that's what we are doing now in this example. That's what you have seen. Okay, now till now this is fine, and the synchronization we have achieved using synchronized keyword. Apart from this, there is one more way as well, that is using manual locks like reentrant locks. Okay, so reentrant lock is a class where it will provide you lock and unlock mechanism. Okay, I will say lock dot lock, and I will say lock dot unlock. Okay, this is also one of the way. Okay, instead of synchronized keyword, but here it won't work because I have creating return lock for each and every call, right? So we should not do like that. So let's create only one lock across the players. So let's create one and pass the lock. Okay, I'm just creating a return lock instead of synchronized keyword. This is another approach to achieve the synchronization. So I will apply the lock here and I will unlock once I'm done. Okay, more customization and more flexibility, that's what we will be getting using reentrant locks. So let's execute that. Okay, see, still I'm getting the synchronization. Okay, and there is one more benefit with reentrant locks. The flexibility what you will get is, if it is a synchronized scope, that synchronized block you will be writing inside a method only, in the sense the start and end of synchronization should be in the same method. But here using reentrant locks, you can lock at one method and you can unlock in another method. Let's see, a user will join to the chat room and he will be there for 5 seconds and then he will leave. Until he left, we can acquire a lock. That is the flexibility we can get. Let's add this, and let's call this here as well. Okay, now a user will join and he will wait for 5 seconds. Assume he will be doing something. 5 interrupted exception, something will be coming. Yeah, oh my god, sorry. Okay, and then a player will leave chat room. Okay, so why exception? Okay, we should pass the lock. Okay, now whenever a player is joined to chat room, I'm acquiring a lock. Until he leaves the chat room, I'm acquiring. After he left, then only I'm unlocking. So this is also a benefit you will be getting with the reentrant locks. So acquired a lock, and till 5 seconds it will hold. Chart region empty. So what happened? Let's see. I will join. Okay, join chart room. We are incrementing it. And then leave chart room. Leave chart room. Numbers count is 1 less than equal to 10. Oh my god, okay, sorry. Rather than this one, I'm sorry, equal to 0, right? So I'm sorry, my mistake. Now execute this, and one member has joined and it has acquired the lock and left the room again, and one more member joined. See, here I'm controlling the locking mechanism, so that's where the synchronization it can be achieved with the reentrant locks. Okay, this is also one of the approach. Now what we have discussed till now is we have discussed the object level synchronization, class level synchronization, and reentrant locks. Now any question you will be getting from synchronization, you will be getting surrounding this concept only. So interview might ask you what is the difference between object level synchronization or class level synchronization, when you will go with class level synchronization, any real-time examples. So basically these are the this is the concept, and I hope you get something. Okay, you understood the concepts. If I didn't confuse you guys much,